Hey guys, Mr. Wilson here. Today we're going to talk about trapezoids and kites. At the end of this video, you should be able to use the properties of trapezoids and kites to find missing side lengths and angle measures. Okay, so remember this from our original quadrilateral lesson, just the definition of trapezoids and kites. A trapezoid is a quadrilateral that has exactly one pair of parallel sides. An isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. Okay. A kite is a quadrilateral with two pairs of adjacent sides congruent and no opposite sides congruent. Okay, and of the quadrilaterals that we study, these are the only two, or the only ones, that are not parallelograms. So now all the parallelograms, the properties and characteristics that we've talked about over the last few lessons, throw those out the window for these two figures. Trapezoids and kites don't play by those rules. Okay, so let's talk about trapezoids. Properties of trapezoids. The base angles of an isosceles trapezoid are congruent. Now, first of all, when we talk about trapezoids, trapezoids in their own, just in the general sense, don't have a lot of characteristics that are consistent. Okay, so when we talk about the properties of trapezoids, they have exactly one pair of parallel sides. That's it. Now, to do anything that's consistent, happens all the time, we'll look at isosceles trapezoids. Okay, so notice that the base angles of isosceles trapezoids are congruent. So when we talk about base angles, we want to make sure that we're showing you that when we look at our trapezoids, the parallel sides are what we call bases. So each trapezoid has two bases, base 1, base 2, doesn't really matter how you name them. Just know that BC is base and AD is a base. Okay, if you identify, this says identify the base angle that goes with angle B. Then find the measure of each angle. So the base angle associated with angle B, notice that B and C are on the same base. So angle C is the one that's associated with it or goes with it. Okay, now that helps us out because remember that we said the base angles of an isosceles trapezoid are congruent. So this is base 1. Those two angles are going to be the same. It's 102 degrees for angle C. Okay, so I'm kind of answering out of order, but that's okay, guys. We can answer it out of order. All right, so other thing we know about trapezoids is that the bases are parallel to each other. And when we think of parallel lines, said it all year, got to make sure you think of alternate interior angles, corresponding angles, same side interior angles. Okay, parallel lines should have those three angles and their properties pop up in your mind. Okay, and so what I see here, I see same side interior angles. Same side interior angles are supplementary, means they add up to 180 degrees. So if this is 102, that must mean that A is 78. 78 degrees. Okay, again, this is base 2. The base angles are congruent. So A and D are associated with each other. D would be 78 degrees as well. Which again, we would be able to use the same side interior angles theorem on this side as well if we wanted to. Okay, so first property of isosceles trapezoids is that the base angles are congruent. Second property of isosceles trapezoids is the diagonals are congruent. So for isosceles trapezoids, the diagonals are congruent. And we should be able to prove that. And that's what they're asking us to do in this proof. It says prove that AC is congruent to BD. Should be pretty straightforward. in the sense that they told us it's an isosceles trapezoid, so we can use that information. First thing here, yeah, why not? I'll reuse red. First thing here, I'm going to use that AD is parallel to BC. It's given. I'm also going to say that AB is congruent to DC, and that's given. Okay, because it was given to us that it's an isosceles trapezoid, basically. Okay, so now what I'm going to do, I'm proving that the diagonals, I'm proving that AC is congruent to BD. And I can do that using these two triangles. So I'm going to redraw them, but I'm going to use BDC. BDC. And I'm going to use ABC. ABC. Okay. All right. And so we've already said that AB is congruent to DC. We've already used that. Hopefully you see here that BC and BC are overlapping. Okay, these are overlapping triangles, so BC and BC are congruent by the reflexive property. Okay. All right. And because this is an isosceles trapezoid, I can see that, is this red? Sorry. Because it's an isosceles trapezoid, then what I know is that the base angles have to be congruent. So angle ABC is congruent to angle DCB. Def of isotrap. Okay. And so because these two are congruent, then what I have two congruent triangles. I can say that triangle ABC is congruent to triangle DCB because of side, angle, side. Because those two triangles are congruent, then I can say that AC is congruent to BD because of CPCTC. Okay, so on a test, am I going to ask you to prove that those two are congruent? Maybe not, maybe. But it's important for you guys to remember that the diagonals of an isosceles trapezoid are congruent, and this is why they have to be congruent all the time. Notice there's no measurements. All we were given in the beginning is that this is an isosceles trapezoid. So we use the fact that this is an isosceles trapezoid to prove that the diagonals have to be congruent. So we know that it's true each time. All right? So for an isosceles trapezoid, okay, remember trapezoids in general, there's not a lot that's consistent all the time. But for an isosceles trapezoid, we know that their base angles are congruent and that their diagonals are congruent. All right, let's talk about kites. Okay, in a kite, the diagonals of a kite are perpendicular. Diagonals of a kite are perpendicular. This problem asks us to find the measure of each indicated angle. We can do that given enough information. So first of all, we know the diagonals are perpendicular, so angle 1 is 90. They tell us that this is 32. So we can find that the measure of angle 2 should be 58. because this triangle has to add up to 180. So 90 plus 32, I'll just call that x, equals 180. So 122 plus x equals 180. That must mean that x is 58. All right. And then we need to find the measure of angle 3. A couple different ways we can do that. The way that I'll use right now is that this is an isosceles triangle. Okay, we know that this angle is 58. Because it's an isosceles triangle, the base angles must be the same. And so that gives us 116. So 180 minus 116 gives us 64. Okay, so this angle up here is 64. We know half of it was 32. So angle 3 is 32 degrees. Okay. That's one way to show that that was 32 degrees. There are other ways. All right. It says to prove in this next problem that angle 1 is congruent to angle 2, and then find the indicated angles. So here's how we can prove that these two angles have to be the same. I'm going to draw a line that's not there to prove it, and then we're going to solve it. Okay, so I'm going to draw this line. I'm going to separate this into two triangles. What I want you to notice about these two triangles is that in these two triangles we have one pair of congruent sides, two pairs of congruent sides, and a shared side. So really, you have three pairs of congruent sides. What does that mean about these two triangles? These two triangles are congruent. Okay, angle 1 and angle 2 are corresponding parts of those congruent triangles, and so therefore they must be congruent. Okay, so that's the proof. By side, 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 we see that these two triangles are congruent, and so angle 1 and angle 2 are corresponding parts of those. They must be equal to each other. Alright, so now we can use that information as well as the polygon angle sum theorem to find the values of angle 1 and angle 2. So, the polygon angle sum theorem says we do 180 times the number of sides minus 2. There are 4 sides, 4 minus 2. So, it should add up to 360. 59 plus 87 gives us 146. So, I'll just call these x. So 2x plus 146 equals 360. 2x then will be 154. Right? No, probably not right. 214, but now I'll do it in the calculator since probably instills some doubt. Okay, so 2x is 214. So then x is going to be 107. So we find the value of x is 107, and that is the measure of angle 1. And like we said, since those two have to be the same, the measure of angle 2 as well. Okay, so properties of kites is that the diagonals are perpendicular. We're able to use that, as well as you see that these two triangles are congruent with that diagonal, creating two congruent triangles, or separating the kite into two congruent triangles, not really creating it. Okay, notice that only one diagonal does that. Sorry, let me make sure I show that. So this vertical diagonal in this case separated into two congruent triangles, but if we were to look at the other diagonal, this does not separate our kite into two congruent triangles, because this is one measure here and these are two totally different measures. Okay, so not both diagonals don't do that. Alright. Now let's look at trapezoids just a little bit, talking about their mid segments. Okay. A mid segment of a trapezoid is a segment that joins the midpoints of the opposite sides of it, or sorry, the non-parallel sides. Let's say that. Non-parallel sides of a trapezoid. The mid segment is parallel to the basis. And its length is half the sum of the lengths of the bases. Okay, so let's find x. Okay, like we said, this is the mid segment. It's the connects the midpoints of the non-parallel sides. And it will be half of 21 plus 35. So what's that, 56? Half of 56 is 28. All right, so now it says if the measure of angle A is 100, I'll just write this in the color here, 100, okay. What is the measure of angle DEF? DEF, okay. So, again, we know that this is parallel. Okay, and so, again, parallel, when we say parallel, we need to be thinking of alternate interior angles, corresponding angles, same side interior angles. So they're asking about DEF. That is a corresponding angle with angle A here. And so since angle A is 100 and corresponding angles are congruent, then angle DEF is also 100. If angle C is 75, okay, then what we can find is EFC right here. Okay, these are same side interior angles, and so the same side interior angles are going to equal 180 degrees. So 180 minus 75 will give us 105 degrees. All right, so there you have it. Those kites, those trapezoids, their characteristics. See ya.